3406. When warm, moist, stable air flows upslope, it A. Produces stratus-type clouds. B. Causes showers and thunderstorms. C. Develops convective turbulence. The correct answer is A. As the warm, moist air is forced to rise along a sloping terrain, it undergoes adiabatic cooling. Adiabatic cooling occurs as the air parcel expands due to decreasing atmospheric pressure with increasing altitude. This cooling leads to the condensation of water vapor in the air, forming clouds. In the case of stable air, the rising air is unable to form large, vertically developed clouds such as cumulus clouds. Instead, it forms a layer of low-level clouds known as stratus clouds. Therefore, when warm, moist, stable air flows upslope, it tends to produce stratus-type clouds. 3407. If an unstable air mass is forced upward, what type clouds can be expected? A. Stratus clouds with little vertical development. B. Stratus clouds with considerable associated turbulence. C. Clouds with considerable vertical development and associated turbulence. The correct answer is C. If an unstable air mass is forced upward, clouds with considerable vertical development and associated turbulence can be expected. In an unstable air mass, the lapse rate, the rate at which temperature decreases with increasing altitude, is greater than the adiabatic lapse rate. This means that as the air rises, it continues to be warmer than its surrounding environment, leading to buoyancy and further upward motion. As the air rises, it cools adiabatically, and if there is sufficient moisture present, water vapor condenses to form clouds. In the case of an unstable air mass, the upward motion is vigorous and continues to rise to higher altitudes, resulting in clouds with considerable vertical development. These clouds are typically cumulus clouds that can grow into towering cumulonimbus clouds associated with thunderstorms. Furthermore, the strong vertical motion in an unstable air mass often leads to turbulent conditions within the clouds. Updrafts and downdrafts can be present, causing turbulent air and potential instability within the cloud system. Therefore, when an unstable air mass is forced upward, clouds with considerable vertical development and associated turbulence can be expected. 3424. Steady precipitation preceding a front is an indication of A. Stratiform clouds with moderate turbulence. B. Cumuliform clouds with little or no turbulence. C. Stratiform clouds with little or no turbulence. The correct answer is C. Steady precipitation preceding a front is an indication of stratiform clouds with little or no turbulence. Stratiform clouds are characterized by their horizontal development and uniform layering. They often cover large areas and produce steady, continuous precipitation. This is in contrast to cumuliform clouds, which are characterized by vertical development and can produce showers and thunderstorms. In the case of stratiform clouds, the precipitation is typically more widespread and consistent, with a steady and prolonged duration. This is often associated with a warm front or a stationary front, where a broad layer of warm air is gradually lifting and producing a steady ascent of moist air. As the air rises and cools, it reaches its saturation point, leading to the formation of stratiform clouds and steady precipitation. Since stratiform clouds are characterized by their layering and lack of significant vertical development, they generally exhibit little or no turbulence. The precipitation associated with these clouds tends to be more uniform and gentle, with a steady and continuous nature. Therefore, steady precipitation preceding a front is an indication of stratiform clouds with little or no turbulence. 3433. The conditions necessary for the formation of cumulonimbus clouds are a lifting action and A. Unstable air containing an excess of condensation nuclei. B. Unstable, moist air. C. Either stable or unstable air. The correct answer is B. The conditions necessary for the formation of cumulonimbus clouds are a lifting action and unstable, moist air. Cumulonimbus clouds, also known as thunderstorm clouds, are characterized by their towering vertical development and the potential for severe weather phenomena such as heavy rain, thunder, lightning, and strong winds. The formation of cumulonimbus clouds requires specific atmospheric conditions. Firstly, a lifting action is necessary to initiate the upward movement of air. This can be triggered by various mechanisms, including orographic lifting, air being forced to rise over mountains, frontal lifting, air being lifted along a frontal boundary, or convective lifting, heating of the surface causing air to rise. Secondly, unstable air is required for the formation of cumulonimbus clouds. Unstable air refers to an atmospheric condition where the temperature decreases rapidly with height, creating a favorable environment for the upward movement of air parcels. This vertical instability allows warm, moist air near the surface to rise rapidly and form towering cumulus clouds that can eventually develop into cumulonimbus clouds. Moisture is another crucial factor for the formation of cumulonimbus clouds. The air needs to contain a significant amount of water vapor for the clouds to develop and sustain their growth. The presence of moisture provides the necessary fuel for condensation and cloud formation within the unstable air. 3409. What is the approximate base of the cumulus clouds if the surface air temperature at 1,000 feet MSL is 700 degrees Fahrenheit and the dew point is 48 degrees Fahrenheit? A. 4,000 feet MSL. B. 5,000 feet MSL. C. 6,000 feet MSL. The correct answer is C. To determine the approximate base of cumulus clouds, we need to find the difference between the surface temperature and the dew point temperature. This difference is called the temperature/dew point spread. In this case, the surface air temperature is given as 70 degrees Fahrenheit, and the dew point is 48 degrees Fahrenheit. Therefore, the temperature/dew point spread is 70 degrees Fahrenheit. 48 degrees Fahrenheit equals 22 degrees Fahrenheit. Typically, for every 1,000 feet of ascent in the atmosphere, the temperature decreases by about 3.5 degrees Fahrenheit. To estimate the cloud base, we divide the temperature/dew point spread by the rate of temperature decrease. 3.5 degrees Fahrenheit per 1,000 feet. 0.22 degrees Fahrenheit divided by 3.5 degrees Fahrenheit per 1,000 feet equals 6.285. Since we want to find the base of the cumulus clouds, we round up to the nearest 1,000 feet. Therefore, the approximate base of the cumulus clouds is 6,000 feet MSL, mean sea level.